Welcome to This Explainer. Today we're diving into the fascinating history, the underlying mechanics, and honestly, the incredible future of wireless communications. We're going to be using some brilliant insights from William Stallings' textbook, Wireless Communications and Networks. So, if you've ever found yourself wondering how on earth we went from massive, clunky radio towers to holding the literal sum of human knowledge right in your pocket, or, if you just want to understand the nuts and bolts of the networks you're using every single day, you are absolutely in the right place. Let's get into it. To really wrap our heads around the sheer scale of the wireless revolution, we've got to rewind a bit to a major landmark year, 2002. Why 2002? Well, according to the International Telecommunications Union, that was the exact moment when mobile phones officially outnumbered fixed-line phones globally for the very first time. I mean, think about that. In just a little over a century since the wireless telegraph was invented, humanity literally cut the cord. It was a massive, fundamental shift in how we interact with each other and the world around us.
Here's our quick roadmap for this explainer. We're going to start by sparking the wireless age, then move into the cellular revolution, explore our desperate need for broadband, look at some cutting-edge future trends, and finally, wrap up with the trouble with wireless. Starting off with Section 1, Sparking the Wireless Age, from transatlantic beeps to satellites. Let's look at how we first solved the massive problem of talking across vast distances without a physical connection.
We can trace this rapid progression really clearly. Back in 1896, Guglielmo Marconi invents the wireless telegraph, sending alphanumeric characters encoded in analog signals. Fast forward just a few years to 1901, and he manages to send a signal entirely across the Atlantic Ocean. That's a staggering 3,200 kilometers. Jump to the 1960s, and we see the first communications satellites launching into orbit. Now, early on, these massive satellites could only handle about 240 voice circuits at a time. It's just wild to contrast that with the 2002 milestone we just mentioned, right? The global mobile boom.
Charting this technological journey from the 1930s through the 2000s reveals a really distinct pattern. If you look at the progression, we've moved from shortwave radio, way down at the bottom, all the way up to infrared and optical communications. Over the decades, our wireless tech has just steadily migrated to higher and higher frequencies. We're talking early FM radio and color TV, straight through to Wi-Fi and ultra-wideband. And the reason for this upward march? It's pretty simple, actually. Higher frequencies are exactly what enable us to push vastly greater data rates and throughput. Which brings us to Section 2, the cellular revolution, shrinking the world. Let's see how all those high-frequency innovations were suddenly put directly into the palms of our hands. The contrast in scale we're dealing with here is just mind-blowing. Back in 1990, the total number of mobile phone users globally was a mere 11 million. Today, we're talking billions of interconnected users. And this explosive, unprecedented growth was totally driven by the sheer convenience of the tech. Mobile phones move with us, Plus, they're inherently location-aware. They communicate with regional base stations at fixed locations, and that allows operators to route services specific to exactly where you happen to be standing. So how did this explosive growth actually happen technically? It wasn't magic, it was a massive shift in the underlying tech. Step 1 was the first generation of wireless phones, which ran on analog technology. Now, these devices were unbelievably heavy, basically giant bricks you had to lug around, and the coverage was, let's be honest, pretty patchy. But they proved that mobile communication was something people really wanted. Step 2 was the game changer, the transition to digital technology. Digital networks could handle significantly more traffic, gave us way better reception, made far more efficient use of our limited radio spectrum, and crucially, they offered vastly improved security over those old analog networks. Of course, once we totally mastered basic voice communication, the human need for data completely took over. That brings us to Section 3, the need for broadband, the data explosion. It didn't take long for the internet to become this intensely multimedia experience, did it? We weren't just sending plain text anymore. Suddenly, the web is absolutely packed with graphics, streaming video, and audio. Business communication evolved right alongside it, suddenly demanding the ability to send massive email attachments. So, to actually participate in this modern digital world, wireless networks had to step up and match the crazy high data rates of expensive, fixed cable connections. But broadband wireless brought something to the table that physical cables just never could: totally unmatched convenience and mobility. Plus, the deployment costs were significantly reduced because, well, operators didn't have to go digging up the streets to lay miles of physical cable. The real hero here, the key solution for our absolutely insatiable appetite for data, was the IEEE 802.11 standard, Now, you probably know it by its much friendlier, everyday name, Wi-Fi. By utilizing free, unlicensed portions of the radio spectrum, manufacturers completely bypassed billions of dollars in licensing fees. This was a massive deal. It meant businesses, offices, and regular households could ditch those expensive physical cable plants entirely while still hitting data rates as high as 54 megabits per second in those early days.
With Wi-Fi paving the way, let's look ahead to Section 4, Cutting-Edge Future Trends Connecting Everything.
We are looking at some seriously fascinating tools working their way through standardization right now. First up, there's WiMAX. Think of this like Wi-Fi on steroids. It's capable of blanketing a massive 40 to 50 kilometer radius just to provide last-mile broadband access. Then you've got MobileFi, which is specifically designed to keep you connected to broadband even while you're flying down the tracks in a high-speed train or riding in a car. On the total opposite end of things, we have Zigbee. This one is built for tiny, low-power sensors operating over short distances. And finally, ultra-wideband. This is designed for moving absolutely massive files. We're talking hours of video over very short distances without getting tangled in messy cords. Zigbee is actually a fascinating peek into the future. I absolutely love this analogy from the source text. Imagine thousands of tiny, cheap sensors scattered all across a massive farm or maybe a giant factory floor, keeping track of temperature or chemical levels. They're engineered to use so incredibly little energy that a single battery can last anywhere from 5 to 10 years. How? Well, they communicate super efficiently, passing bits of data over radio waves from one device to the next, working together like a bucket brigade for years and years until that data finally reaches a central computer. It is just a brilliantly elegant solution to a really complex networking problem.
But as you might guess, building this seamlessly connected future isn't exactly a walk in the park. That brings us to our final section, Section 5, the trouble with wireless, bumps in the road. One of the absolute biggest hurdles we face is a severe lack of industry-wide standards. Just to give you an idea, in North America alone, we've had completely clashing digital cellular standards like PCS IS-136 going up against PCS IS-95. If your phone uses one, it literally will not work in a city that only deployed the other. And on top of that political fragmentation, you've got hard physical limits like frequency interference. Technologies like Bluetooth and 802.11 Wi-Fi often share the exact same frequency band. So if they're put into the same device without some really careful engineering, they can actively jam each other, dropping your connection at the exact moment you need it most. Beyond the invisible airwaves, we also have to deal with the physical limitations of the devices themselves. Mobile devices have really small displays, which, especially in the early days of the mobile web, were terrible for reading long lines of text. Because of this, early mobile browsers couldn't even load standard HTML websites. They had to rely on a special, stripped-down language called Wireless Markup Language, or WML. And sure, our phone screens have definitely grown since then, but that fundamental tension, the trade-off between having a perfectly portable device and wanting a full desktop-like web experience, that remains a constant, everyday engineering challenge. The source material actually brings us right back down to earth with a really grounded takeaway. Most likely, no one wireless device will be able to meet every need. As much as we all want that one single magical gadget that does absolutely everything flawlessly, the true potential of wireless is actually going to be met through a diverse ecosystem of specialized devices. You might use MobileFi in your car, rely on Zigbee sensors for your smart garden, connect to Wi-Fi in the office, and stream via ultra-wideband in your living room. Wireless succeeds specifically because it can be integrated into 1,000 different forms to meet 1,000 different needs. So as wireless tech continues to rapidly evolve all around us, constantly shifting to higher frequencies and connecting more and more of our physical world, I want to leave you with a final thought to mull over. Will true, seamless, ubiquitous access ever actually be achieved globally under one single unified standard? Or is the beautiful, messy reality of our future destined to be a patchwork of 1,000 different devices, all chattering away in their own specialized languages? Thanks so much for joining me for this explainer, and definitely keep your eyes on the invisible waves all around you.